Wednesday's problem says find all the zeros for the polynomial f of x equals x to the fourth plus x cubed minus 3x squared minus 17x minus 30. The problem says to start by making a list of possible rational zeros, that's your p's over your q's, and if you use a graph to assist your selections, show it. Hint, this is from chapter 2. So to make your list of p's and q's, that's what they want us to start with. Remember that p's are factors of your ending constant, which in this case is negative 30, and q's come from the leading coefficient, which in this problem is a 1. So my possible p's are plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 5, plus and minus 6, plus and minus 10, plus and minus 15, and plus and minus 30. So those are all the different numbers that divide evenly into negative 30. And q, the factors of 1, are just plus and minus 1. So normally what you would do is you would take all your p's and divide them by all your q's, but since my q's are just plus and minus 1, these numbers would not change. So the numbers listed as the factors of p are also your p's divided by your q's. So I'm not even going to make another list. The next thing that you should do is you should type this formula into your graphing calculator. We are not just going to get our answers off the graph, because sometimes there's answers you can't see, but we're going to use our graph to help us get the answers that we can see out of the problem to make it easier to find the rest of the answers. So this graph over here represents what my graphing calculator showed me when I plotted this equation. It appears as though there might be a solution at negative 2, and it also looks like there might be another answer at positive 3. Zeros are places where your graph hits the x-axis, if they're real. Anyways, one other thing that I want to mention before we get started with our process here. The highest power on x, which in this case is 4th degree, is going to tell us exactly how many answers we're supposed to be looking for. So because this was a 4th degree polynomial, that means there are 4 zeros for us to find. If you do not end up with 4 zeros, you have not found all the answers to this problem. So what my plan is, I'm going to pick the ones that I can see from the graph and use synthetic division to remove them from the formula. So the first synthetic division that I tried, it looks like negative 2 is going to work. So put a negative 2 out in front. Remember, synthetic division removes all the x's, and you're just using the coefficients. So when I carry out this synthetic division, I see that it works because the remainder right here turns out to be 0. That's the dead giveaway as to whether something works or it doesn't. The remainder needs to be 0. And that means that x equals negative 2 is definitely an answer to this problem. When you've completed one successful synthetic division, don't ever go back to the original coefficients anymore. What you want to do next is you want to pick up with the coefficients where you left off. So use the numbers from your previous quotient. Don't go back to the original. So I'm going to use this 1, negative 1, negative 1, negative 15 as the numbers inside of my next synthetic division. And I'm going to go to my graph and I'm going to pick the next number that I think works, which is, I think 3 works. So this is me doing a synthetic division using the number 3 out in front. So I go through the synthetic division process, and again, I find out here that the remainder turns out to be 0. That indicates to me that x equals 3 was an answer to this problem. And I have now removed the 2 answers that I can see in my graph, and this thing right down here, 125, the quotient, contains the coefficients of a quadratic. That's going to be the way that I find the last 2 answers to this. So I tried to think of 2 numbers that would multiply together to make 5 and add together to make 2. I couldn't think of any. So I had to go to using the quadratic formula. Negative b plus and minus the square root of b squared minus 4 times a times c, all divided by 2a. So when I plug all the numbers in, I get negative 2 plus and minus the square root of negative 16, all divided by 2. The square root of negative 16 is 4i. So we have negative 2 plus and minus 4i divided by 2. And since everything on top is evenly divisible by 2, I reduce this. Final answers for the 2 imaginary answers that I cannot see are negative 1 plus and minus 2i. These 2 answers, together with the 2 answers that I found by synthetic division, represent the 4 answers for this problem. Remember, your degree tells you how many answers you must find, so you're not done until you get, in this case, all 4 of the answers to the problem.